Hi class, we're in chapter 14, lesson 4. And we've already alluded to this lesson in the previous ones, but this is where we're finally going to look at making this transition from being able to find the area and perimeter of a regular polygon to being able to find the area and perimeter or circumference of a circle. Okay, so we'll look at how those are related and how Archimedes made that connection between them. Okay, so we can see here we have a hexagon that's inscribed in a circle. You know, we've talked before about polygons being inscribed in a circle. Each of its vertices lies on the circle. Okay, and as our book says here, the 6 arcs of the circle are obviously longer than these chords, right? So arc AB is longer than chord AB. You can think about if this was a string that was tied to these two endpoints, that string would have to be longer than that chord. Okay, so Archimedes started adding sides. And what he would do was just double the sides. So you can see here, if I were to draw, let's say I put a point here, and then I just draw this, so I make a triangle with this side of the hexagon as its base. So now that I have 2 new sides, if I do that all around my figure, then I'm going to end up with this. So there's that side of my hexagon, and now I have a 12-sided figure, a dodecagon. So he doubled, he did 12, 24, 48, and then eventually got up to 96. And the more sides he used, you can see he gets closer to being a circle as he adds more and more sides. Okay, so when we talk about the official formula for pi, it's going to talk about as n, the number of sides, approaches infinity. So as we can see here, here's 6 sides, okay, and then 12 sides and 24 sides, and by the time you get to 48 sides, it's almost indistinguishable from a circle. But he actually goes one more step beyond that to 96 sides. So the closer and closer you get to an infinite number of sides, which we can almost think of a circle as like every point on the circle being a side, which would be like an infinite number of sides. The closer and closer you get to an infinite number of sides, the closer and closer you get to the actual circle. And so we put our definition of pi usually in terms of this kind of a calculus thing, as n approaches infinity. Okay, so as n, the number of sides, gets bigger and bigger, and it gets closer and closer to infinity. Okay, then we get closer and closer to being a circle. But there's a limit to, as we get bigger and bigger, the number here grows, right? That number n, this is the formula we looked at previously, and n keeps getting a little bit bigger as the number of sides gets bigger. You can see here, with 48 sides, with 96 sides, that's where Archimedes went. And then this other Chinese mathematician, whose name I'm not going to try to pronounce because I'll do it wrong, he kept going all the way up to 3,072 sides. And you see we get closer and closer to our modern day approximation of pi, okay? But there's a limit, okay? Because the outer bounds of the circle, that is, so if you see the red line, it's the circle. The outer limit of the circle that the polygons are inscribed in doesn't change. So as you add more sides, you get closer and closer to the circle, and so that area increases so that you're filling in all these holes. But as you add more sides, you're not going to go outside of the circle, right? You're going to get closer and closer and closer to filling in that whole circle so that you won't have these gaps left. But you don't then go past the circle, okay? So we say that there's a limit to how much bigger that perimeter or that area could get, okay? So the perimeter will get bigger as we add more sides, right? If I draw those triangles there, now that perimeter for the 12-sided figure is going to be bigger than this perimeter. We can see that. We can also see that it fills in more area, but it can't get bigger than the circle that it's inscribed in, the circle that circumscribes that polygon. Okay, so that's its limit. So when we talk about limits in calculus, as you'll hear about, the limit of this, we usually say the limit, and LIM is just our abbreviation for limit. We usually talk about the limit as n approaches some number. Sometimes it might be like as n approaches 3. In this case, it's as n approaches infinity. As n gets closer and closer to infinity, we get closer and closer to this limit of the area or the perimeter. Okay, so that's how pi was really calculated, is this limit as we get closer and closer and closer to an infinite number of sides. Okay, so you can see here, if 2 pi r is the circumference of a circle, you can see we get really close to that as the number of our sides increases. Okay, so that's how it was approximated for many, many, many years. And really all any improvements that we've done since then on our accuracy of pi are just from computers and calculators that are able to go beyond these numbers of sides to larger and larger and larger circles, so you can get a better approximation of pi. Now, the remaining formulas that we have here are ones that I would guess you already know. If the radius of a circle is r, its circumference is 2 pi r. Or you could say if the diameter of a circle is d, its circumference is pi times d. And those, essentially mean the same thing, since the diameter is equal to 2 times the radius. Okay, so we finally made it to our circle formulas, but we can see from the previous lessons how those came from the area formula for a regular polygon and the perimeter formula for a regular polygon. Okay, that's it for lesson 4.